Okay, in this presentation we are going to look at continuous random variables. Here we have a continuous random variable x, and it has the following probability density function given in terms of theta, which is the parameter of the distribution. So here we have it here. F of x equals 2x divided by theta squared, where x is between 0 and theta, and it is 0 otherwise. So this is the key part here, this one. Okay, so this will actually inform us what the limits of our integral should be when we start doing definite integrals. Derive expressions in terms of theta for the expected value and the variance of x, and later on what we're going to show is that we have a sample here of values of x, and we have a mean of that sample x bar from the distribution of x. Show that the estimator theta hat or hat theta equals 3x bar divided by 2, show that that estimator is an unbiased estimator of theta. Okay, so let's begin. Let's look at the expected value and the variance of x in terms of theta. Okay, so the expected value of x, as always, is x times the probability density function of x, and here we so essentially get the integral of that. Okay, and here the limits are 0 to theta. Okay, so far so good. So x times f of x is x times 2x divided by theta squared, which is 2x squared divided by theta squared dx. Okay, so this integral is in terms of dx, so essentially theta squared is a constant. So what we have here is essentially the key part here is 2x squared. When we integrate that, we will get 2x cubed divided by 3. Okay, and then also we have the theta squared there. So the expression becomes 2x cubed divided by 3 theta squared, from where theta is, x it goes from 0 to theta. Okay, the upper and lower limits of the integral. Okay, so we evaluate this expression for theta and then 0. Now we can just disregard 0 because it just goes to 0. So 2 theta cubed divided by 3 theta squared, okay, is what we would get. So theta squared cancels out, and we are still left with the 2/3 there. Okay, so essentially the expected value of x is 2 theta divided by 3. Okay, so we have to get the variance of x, and to get the variance of x, first off what we must do is get the expected value of x squared. Okay, same process. The key part here is x squared times the probability density function, and get the integral of that from 0 to theta with respect to dx. Okay, so it's very similar in this particular instance. It's a straightforward enough integration, really. So x squared times 2x divided by theta squared. Okay, so we have 2x cubed divided by theta squared dx. Get the integral of that. Okay, so we could just treat theta squared as a constant and look at 2x cubed. And when we integrate 2x cubed, we will get 2x to the power of 4 divided by 4. Then we have theta squared there, so bring that in. And it's a definite integral from 0 to theta. Okay, so what we do is evaluate it at both theta and 0. Again, 0, when we evaluate it at 0, 2x to the power of 4 is 2 times 0 to the power of 4, so the whole thing just becomes 0. So essentially what we have here is x squared divided by 2. Okay, so the theta to the power of 4 divided by theta squared is essentially, when we divide that down, we just end up with theta squared, and 2 divided by 4 is just simply 1 over 2. So we end up with theta squared divided by 2. Okay, and again we can disregard the 0 part. Don't always do that, just check it, but I just mentally noted that I can just disregard 0 here because it's just 2x squared. If there was a constant there, you might have to do something with it. So, using these results, what we can do is calculate the variance of x. Now we're going to use this formula, which I hope you're familiar with, this identity. The variance of x equals the expected value of x squared minus the expected value of x to be squared. Sorry, I should have a 2 there. That's a superscript. Okay, so theta squared divided by 2 minus 2 theta divided by 3 to be squared. Okay, so theta squared divided by 2 minus 4 theta to the power 4 theta squared divided by 9. Little bit of algebraic manipulation and rearrangement, we get the variance there is theta squared divided by 18. So the second part is the sample. Suppose that this sample is a random sample of values from x with a mean x bar. Okay, show that the estimator hat theta, or theta hat if you prefer, equals x bar 3 times x bar divided by 2. Show that that is an unbiased estimator of theta. Now this is straightforward enough really. So what we're told here is that the expected value of theta hat equals the expected value of 3x bar divided by 2. Okay, so we could just take out the constant terms there. So we have 3 over 2 times the expected value of x bar. Now the expected value of x bar is by definition the expected value of x. Okay, so therefore what we end up with is 3 divided by 2 times 2 theta divided by 3. 3 over 2 times 2 theta over 3, and that works out to be theta. Okay, so the expected value of theta hat is theta, so that means that this is an unbiased estimator of theta. Okay, we'll leave it there.